welcome to the lesson on Intro to the Electron Cloud Model. As I've been saying, you're going to see that this unit is going to feel a lot different than the units that we've been doing previously, and most of this stuff you have already learned as 10th graders. So before we go into the Electron Cloud Model, we need to review the Bohr Model. So let's say we wanted to draw a Bohr model of an atom of, let's say, I don't know, we'll do magnesium. All right. I'm going to switch over to Smartboard software. Hold on one second. So what Bohr said that in the nucleus of an atom, there are protons and neutrons. And so for magnesium, the protons are 12 for magnesium. And the neutrons are also 12 for magnesium. Lost my nucleus. And the reason why the neutrons are 12 is that the atomic mass of magnesium is 12, minus the protons, which is also 12. And then this is sort of the most important part of what he said, that there are circular paths, which he called orbits, that electrons travel around. And he said that there were, why can't I speak? Neutral magnesium has 12 electrons. And he said in the first energy level, the first orbit, there are 2 electrons. And then in the second energy level, you can hold 8. 6, 7, 8. And then in the next energy level, which holds 18, we would put the rest. So we have 10 so far to count. 1, 2, 3, 4, 5, 6, 7, 8, 9. Did I miscount? 1, 2, 3, 4, 5, 6, 7. I'm missing an electron. So that's 10 total, and we need 2 more on the third energy level, which can hold 18, but in this case only needs 2. And our valence electrons here, which are going to be really important coming up, are 2. Remember, valence electrons are the electrons in the outermost energy level. Now, so Bohr, while a nice model to sort of like think about, because it's like sort of circular, the Bohr model is not the most accurate model of the atom. Okay, the actual sort of most accurate model of the atom is called the Electron Cloud Model. And as I scroll back up to the beginning of the PowerPoint, and if we look at how the Electron Cloud Model, okay, is different from Bohr and the same as Bohr. So in the Electron Cloud Model, the protons and neutrons are still in the nucleus, and electrons still travel outside of the nucleus. However, okay, electrons do not travel in circular paths. They're not orbits. Okay, they don't travel in circles around the nucleus. They travel around the nucleus, but their path is not essentially a circle. And what's also important, we're going to see in a second, and hopefully you remember, is that energy levels are further subdivided into sublevels and orbitals. What the Electron Cloud Model does is it predicts the location of an electron with about 90% accuracy. And it sort of draws an area of 3D space and says that the electron will be located in this 3D space 90% of the time. The other 10% of the time it won't. And again, these functions that they came up with are very, very complicated, involving multivariable calculus and all this craziness. But if you look at this picture, okay, this is an example. So let's say this is the nucleus, and we're looking for maybe the location of an electron in, I don't know, let's say beryllium. What the Electron Cloud Model does, it draws these areas of 3D space that say the electron is going to be in this 3D space 90% of the time. Okay, obviously the more dots, the more likely it's to be in that 3D space. Okay, now we're going to go through the Electron Cloud Model parts. And the first part, which is no different than Bohr, is energy levels. And at Bohr, actually, we call them orbits and not energy levels. Energy levels is sort of the Electron Cloud Model term. Okay, now, energy levels are further subdivided into 1 or more sublevels. Okay, and those sublevels are named S, P, D, and F. And I had made up an acronym, if you remember, in 10th grade. Smart people don't fail, which I don't know if that's true anymore, but whatever. But anyway, so there are sublevels are subdivisions of energy levels, and there are 4 of them: S, P, D, and F. The first energy level has 1 sublevel, and its name is S. You can sort of see the pattern that's developing. The second energy level has 2 sublevels, and they're named S and P. The third energy level has 3 sublevels, named S, P, and D. And the fourth energy level has 4 sublevels, named S, P, D, and F. So you can sort of see the pattern that emerges. The AP exam does not go past, in terms of knowing the sublevel. There is a GE sublevel as well, but we don't need to know that for the AP exam in the 5th energy level. The 5th energy level does have 5 sublevels, though. So we have energy levels, which are subdivided into sublevels, and then sublevels are further subdivided into orbitals. And orbitals is sort of an important vocabulary word. The orbital is the area of 3D space that an electron is most likely to be found. Okay. Now, if you look at this chart down here, okay, what this chart is telling you is that the S sublevel has 1 orbital, the P sublevel has 3 orbitals, the D sublevel has 5 orbitals, and the F sublevel has 7 orbitals. Okay. Now, if you can remember how to remember this, these are odd multiples. So starting with S has 1, then 3, 5, 7, and so forth. If you need a way to remember that, because you do need to remember it. Now, what's also true is that each orbital can hold 2 electrons, and they have to spin in opposite directions, which we'll see in a drawing in a second. So, the AP exam rarely tests this, but I'm just going to put it there just in case, because there's been like one question I've seen about it. So, depending upon the letter orbital that you are, okay, the orbitals have different shapes. So this is a picture of a 1s orbital. And what this says is that in this sort of like dot diagram, the electron is likely to be in this 3D space 90% of the time. This is the 2s orbital. Notice that the dots are more dispersed, and they're further out because the 2s orbital is further from the nucleus than the 1s orbital. And then if we look at shapes of p orbitals, and the formatting here got messed up, p orbitals form these lobes. And so this is the 2p, and so instead of being circular, they now have these like lobes. And you notice that the 2p, this is the 3p, you notice that 3p is more dispersed than the 2p, because the 3p is further away from the nucleus. Sorry, the 3p is further away from the nucleus than the 2p. And there are 3 p orbitals, if you remember from our diagram, and they are located in either the z, x, or y plane. So we say this one is in the z plane, this one is in the x plane, this one is in the y plane, and this one is in the z plane. And that's going to be actually important when we do some bonding later at the very, very, very end of the year. Okay, now, the next slide is what you really, really, really need to sort of get. So we're going to move over to the smartboard software. And because this is sort of like the whole point of this lesson here, as we get to the right slide. And as I'm adding additional slides, we'll get there at some point. Alright, so the first energy level is the most simple one. Okay? So the first energy level, okay, has one sublevel named S. Okay? And in that S sublevel there is one orbital, which can hold 2 electrons. Okay. So this here is the orbital, the S orbital. Okay. Now the second energy level, okay, has 2 sublevels. One is S and one is P. Okay. S can hold 2 electrons, has one orbital which can hold 2 electrons, and the P sublevel has 3 orbitals, each which can hold 2 electrons. And again, I'm drawing the arrows up and down because they spin in opposite directions. Okay. Then we have, and I'm going to scroll down more if I can. Okay. Now the third energy level, okay, has 3 sublevels, S, P, and D. Okay. D has 1 orbital, electrons going up and down. P has 3 orbitals, electrons going up and down, opposite spin. And D has 5 orbitals going up and down, which is annoying to do. Alright, and then last but not least, our fourth energy level. Our fourth energy level has 4 sublevels, S, P, D, and F. Okay, and again, 1 orbital for S, 3 orbitals for P, and I'm getting tired of doing the electrons. D has 5, and I'm sort of running out of space. 4, 5, that's 6. Lame. electrons going up and down, opposite spin. And then F has 7, which is annoying to draw. So there's 7. And again, I'm not going to add the arrows, but they go up and down. You can add them for yourself going up and down. Okay, so that's what each energy level looks like, or the sublevels and orbitals in each energy level. And you should be able to say, okay, well, how many orbitals does a fourth energy level have? You should be able to sort of recreate this diagram. If we look at calculating maximum number of electrons in an energy level, the first energy level can hold 2. The second energy level can hold 8. The third energy level, if we counted 2, 4, 6, 8, 10, 12, 14, 16, 18. And then last but not least, the fourth energy level, as I scroll down. The fourth energy level can hold 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32 electrons. Alright? But you need to sort of be able to recreate this diagram for yourself following the rules. So the last thing that we have to talk about in this lesson is how do the electrons fill these orbitals. And you'll be sort of like surprised, and you might remember to say they don't fill them in order. Like it doesn't fill all the first energy level. Well, actually, it does with the first energy level because there's only one. But it doesn't fill all the third energy level sublevels before the fourth. Okay, the rule is, which was determined the Aufbauen principle, is that electrons are placed in the lowest energy available lowest energetically available sublevel or orbital. Okay, so I don't know if one of the things you may remember is that when we were doing this, like 1s2, 2s2, is that the 4s actually fills before the 3d. And that's because the 4s has lower energy than the 3d. What makes it have lower energy, okay, is that the 4s is actually closer to the nucleus than the 3d is, and therefore has lower energy. Alright, now, so again, the point here is that orbitals fill with electrons from the lowest energy available sublevel forward. As you go add more electrons, the energy of the sublevel or orbital increases. Now, this is the diagram, okay, that helps you remember the order. Okay, you need either to know the order or memorize the order, or be able to produce this diagram. If you think about what it is, okay, it's like in here are all the S sublevels, then we skip a spot. Here are all the P orbitals, skip a spot, all the D orbitals, and all the F. Actually, these are sublevels. So, again, so the order, if you read up the diagonal, so the first one is 1s, then we have 2s, 2p, 3s, 3p. Now here's where we skip something. 4s, so if we have a 4 sublevel filling before the 3 is done, then 3d, 4p, 5s, 4d, 5p, 6s. Notice we fill a 6s before the 4f, 5d, 6p, 7s, 5f, 6d, 7p, 6f, 7d, and then last but not least 7f. And again, they like to ask, AP exam likes to ask questions. They'll give you some sublevels, and they'll ask you to order them from highest to least energy, from least to most energy. And as you go up this diagram, the amount of energy is increasing. And again, you need to be able to produce this diagram, or at least get the order. Wednesday in class, I'm going to show you like a trick with the periodic table of how to get the order. But we'll see you guys on Wednesday. Answer the guided questions. Have a good afternoon, evening, morning, whatever it may be.